Hey guys, so today I'm going to be trying to teach you how to model diseases, or basically how to find out how many people will get infected with a disease or an infection after 1 day or 2 days or 3 days. I think this is super cool, especially because you can apply it to the real world as well. So if you take a real life virus, like the coronavirus, for example, or even something like the flu, you can track how many people have been getting infected every day and use that to find out how many people will get infected tomorrow or next week or next month. So basically, you could predict the future with which I think is pretty cool. So the way this works is you have a certain number of healthy people, right? These are the healthy, happy people that aren't infected with anything. So for the purposes of this, let's say we have 400 healthy people in our population, right? Then you have the infected people. The infected people are obviously the people that are infected. So for this, let's say we have just one infected person. And then, lastly, you have the recovered people. These are the people that have been infected at one point, but they recovered, and so now they're not infected anymore. And let's say we have 0 people, because this is a relatively new zombie outbreak. And not many people have the infection. And also for this, let's say if you have been recovered, you can't get infected again. So that'll keep things simple. So you might be asking, how do you actually find out how many people will get infected the next day? Well, that's where this equation comes in. So this equation is basically, you take the number of healthy people, H. I don't know why it's showing up weird. H, okay, there we go. Right, and you multiply it by the number of infected people, and then you take that and you multiply it by this number. So that is the rate of infection. So for this, it's 0.02, which I'm just going to say right now is pretty high. What the rate of infection is basically how fast the disease spreads, how fast the infection spreads, right? How easy is it for somebody to spread it to somebody else? So the higher this number is, the faster it's going to spread. The lower the number, the slower it's going to spread. So when you're modeling your own disease or hypothetical infection, and you're an evil person and you want everyone to get infected, then use a really high number. This is a pretty high number. Normally you want to go somewhere around 0.01. That's the normal-ish amount. But I chose 0.02 because I'm a bit evil. So that's how you find out how many people go from healthy to infected after a day. So then, if you want to find out how many people go from infected to recovered, you use this formula. You take the number of infected people and you multiply it by the rate of recovery. The rate of recovery. So what this means is basically how fast do people recover from something? How easy is it to get rid of the virus or the infection or whatever? So again, if you're evil, you're going to make this number pretty low so that people recover way slower, right? But if you're a good person, you'll make it pretty high. I made it pretty high just to cancel out the evilness from the pretty high rate of infection. So now we could start applying this to our numbers over here. So let's take our healthy population, which for this is 400, right? We have 400 healthy people. And then we can multiply that by the number of infected people, which is 1, right? And we multiply that by the rate of infection, which is 0.02. So we know this, 400 times 1 is just 400. That's easy. So now we just multiply 400 by 0.02, and we get 8. So what this 8 means is 8 people go from healthy to infected. So if we subtract 8 from our healthy population, we get 392. So now our healthy population is 392, right? if we want to find out how many people are recovered, we use the recovery rate equation, this thing. So we take the amount of infected people, which in this case is 1, and we multiply that by the rate of infection, which is 0.4, and we get, well, 0.4. You might be asking, well, how do you recover 0.4 people? That's not really a thing. You either recover 1 person or 0. There's no in between. So for the purposes of this, we're going to say whatever number it's closest to, that's the number. So 0.4 is closer to 0 than it is to 1. So we're going to say the amount of recovered people stays exactly at 0. So now, since we still have 1 infected person, and we added this 8, now we have 9 infected people. Right? 9 infected people. And it's going to start spreading a lot faster than it is right now. Because, again, this equation takes into account the number of infected people. So the higher this number, the higher number of people will get infected the next day. So let's do it again, right? We take 392 healthy people times 9 infected people times 0.02. Okay, and I already did this before. You get something around 71, right? So 71 people go from healthy to infected. So that's 392 minus 71, and then you get 321, right? So we have 321 healthy people left. Pretty simple. If you want to find out how many recovered people there are, let's just use this equation again. So that's 9 times this number, so 0.4, and that is equal to 3.6. Again, for this, we're going to say it's closer to 4 than it is to 3, so basically 4 people recovered, right? So 9 minus 4 is 5, and then 5 plus 71 is 76, which means 76 people are infected. Here's where it gets fun. This is where you get to see how high this rate of infection really is. Because the next step, well, you'll just see you have the amount of healthy people, so 321, multiply it by 76. This is going to be a really high number already, and then times 0.02. You get something that's higher than this. If you get a number that's bigger than that number, that means all of those people will get infected. So basically what that means is we have 0 healthy people left, and they are all infected. If we run this equation again, we get 76 times 0.4, we get around 30. So now we add 30 to our recovered population. So now we have 34. And then the rest of those is around 367. And, well, we know nobody's going to be adding to this column, so we could just put 0 for the rest of these. And I already did the calculations beforehand. You can do these if you want, but it's pointless, right? After a while, this population goes down, and this population goes up. 181, right? And this one goes to 132, and this one goes to 269. So yeah, there's going to be a lot more recovered people and less infected people as time goes on. So yeah, that's about it. You can mess with this by yourself. You could change the number of healthy people to start with, change the number of infected people to start with, change this number and this number. Those are the biggest ones, because how much you change those numbers can drastically affect how fast people get infected and recovered. So I think it's really fun to mess around with. But yeah, that's about it.